So that's also why I always come as a pair, because you notice a pair because these are conjugates and these are complex conjugates. So it actually makes a lot of sense because these are sort of not the integers or the rational numbers that we are used to. So meaning that to separate that, you sort of get two pairs. That makes sense. So it sort of makes sense to me because normally for me I normally won't use irrational or complex imaginary zeros. So I sort of think of it as a separation, like half of a rational number. So that's complex, and should I leave this here? Okay, I should leave this here. And so we've gone over the definition of a zero and the value of x, f of x. So now let's go over factoring. Factoring. This is the chart. Can we just erase it? So I have to go over factoring before we can actually make it to factoring. So you can just look at this graph. It's very hard to digest in such a fast way, but I personally, so I don't I don't think it's helpful to memorize this formula. I think in a way it's for me. I wouldn't memorize this. I would memorize the other way. I would memorize it as a plus b squared equals a squared plus 2ab plus b squared, and a minus b squared equals a squared minus 2ab plus b squared. I would memorize it like this instead of working on x, because many times you have to expand it, and expanding it I think it develops more. So I'll teach you another way to sort of factor not just perfect square trinomials, but factorable trinomials. So I will substitute this into this because I don't think this formula is actually really helpful, to be honest. Because the so you can just sort of quickly memorize this. Remember, common mistake would be this and this are different. This and this are different. So I just want to point that out first. So, for example,